Hello everyone, we are presenting our project titled Intrusion Detection System for Control Area Network. This project is developed by Mahendra Nimse, Atharva Ugale and Rohit Thorat under the guidance of Professor Amit V. Nagrale. This is a part of Embedded Linux System course of the academic year 2025 and 2026 at the School of ENTC Engineering, MIT. In this presentation, we will explain the problem of CAN bus security and how our intrusion detection system helps improve vehicle safety. Introduction. Modern vehicles have evolved from simple mechanical system into advanced cyber physical system. They consist of multiple electronic control units, sensor, and actuator that constantly communicate with each other. The Control Area Network or CAN bus is the most widely used in vehicle communication protocol due to its simplicity, reliability, and real-time performance. However, CAN was designed without considering cybersecurity, which makes today's connected vehicles vulnerable and cyber attacks. Then our problem statement. The main problem is that the CAN bus does not have a built-in security features such as authentication or encryption. If an attacker gain access to the network, malic- malicious message can be injected into the CAN bus. Such attacks can control or disrupt critical vehicle functions, leading to serious safety risks. Therefore, a real-time intrusion detection system is required to continuously monitoring CAN traffic and detect abnormal behavior. Then, problem system application. The system has a several important application in automotive domain. First was at automotive cybersecurity. It improves the automatic cybersecurity by protecting the CAN network from both wireless and physical attacks. It provides ECU level protection by detecting abnormal behavior from compromised ECUs. It ensures safety in autonomous and ADAS system by preventing manipulated sensor data. It also helps in vehicle diagnostics, theft, prevention, and academic research in intelligent transportation system. Then working principle. Uh, Let us now understand the working principle of our system. First, CAN data is continuously collected using a socket CAN and the Raspberry Pi. Next, important features such as the message ID, frequency, and time interval are extracted. These features are then analyzed using machine learning algorithm like random forest or SPM. If any abnormal behavior is detected, the system immediately generates the alerts and logs the event all while operating in real time. Then this slide shows the interfacing diagram of our system. The Raspberry Pi acts as the central intrusion detection node. It is connected to the CAN module, which is communicate with ESP8266 ECU node. These ECU nodes generate the both normal and malicious CAN messages to test the performance of our system. And this is our hardware component. Now, the Raspberry Pi is the core processing unit where the intrusion detection logic runs, and the MCP25 15 CAN controller provides the interface between Pi and the CAN bus and support high-speed communication. The ESP8266 module simulate a uh, real vehicle ECUs and helps to generate attack scenarios. Now, for software, we use multiple tools like Arduino IDE to use to program the ESP8266 nodes. Python is used on the Raspberry Pi for data capture and intrusion detection. Google Colab is used to train machine learning models. Machine learning libraries such as scikit-learn help implement the classification algorithm. This is our snapshot of our actual hardware setup and system execution. These images show CAN communication data monitoring and intrusion detection working in real time. And conclusion, the conclude modern vehicles required a strong cyber security solution. Our project successfully demonstrate a real-time intrusion detection system for CAN network using machine learning technique. It is capable of detecting multiple types of attacks while maintaining the low latency. And future scope, in the future, the system can be enhanced by using deep learning models, encryption mechanism, and advanced CAN protocol, such as a CAN-FD. Real vehicles testing, large-scale deployment will further improve its practically uses.
So this is the hardware setup for intrusion detection system. This is the ESP8266. It works as a sender node. This is MCP2515 CAN module. It is used to send the CAN frames through these two wire connections that are high and low, and it will receive at this MCP2515 CAN module, and it will be sent to this Raspberry Pi. So to send the data, we have written some Arduino code. Here is the Arduino code. In the Arduino code, I have hard coded some CAN frames, so in which there are some normal data plus attack data, like impersonation attack IDs, fuzzy attack IDs. Yes, yeah. So here this monitor is connected to the Raspberry Pi. So if we run can dump can 0, it will display the can IDs that are sent through the ESP32, and it will and so this is the IDs that are received from ESP32 at Raspberry Pi. And here we have ids.py file where we have designed a dashboard where we have used AI/ML model to detect the IDs. So if I run the ids.py, it will take some time and the dashboard will be open where attack will be predicted. So it will take some time and dashboard will be open. So this is the dashboard. These are the IDs received here. Each ID is shown here plus the data length, data and interval between each ID. So if data is normal, simply normal is shown, and if the ID contains attack frame, then red alert is shown. So impersonation attack is being detected. So in dashboard the alert is displayed. Yeah, and this is the complete setup. Thank you.